Okay, so we've been simplifying radicals. I've got a couple here for you to do. First, let's talk about the rules of simplifying radicals. Okay, I know I've showed you this before. It says an expression containing square roots is in simplest form when the first bullet says the radicand has no perfect square factors other than 1. For instance, this square root is not simplified. And you know that it's not simplified if you've got variables and the power is greater than 1. If the power of the variables is greater than 1, say 2, 3, 4, 5, 6, 7, it is not simplified. This is simplified form. I took this same one, the square root of x to the third, y to the third, and I wrote it out in expanded form, x times x times x, y times y times y. My index here is 2. So I put together groups of 2 so they'd come out as a single, and this is what I got for my answer. I know this is simplified because the exponent on both of those variables is 1. And like I told you, if your exponent on your variable as a radicand is any number bigger than 1, it is not simplified. Okay? The next bullet says the radicand has no fractions. Okay? Here, the radicand is a fraction that is not simplified. You have got to use your property, your quotient property of radicals, separate the two apart, and now the square root of 4 is 2. This is simplified. I no longer have a radical in the denominator. The third bullet says there are no square roots in the denominator. We don't like square roots in the denominator. We have got to get that square root out of the denominator. So I'm going to multiply by a form of 1. The square root of 2 over square root of 2 is 1. When I multiply my numerator together and my denominator together, this is what I get. I'm going to put these back together, the square root of 2 times the square root of 2, using the multiplication property of radicals. And now the square root of 4 is 2. I no longer have a square root in the denominator. I am simplified. There is no perfect square factor under the radical sign. I am simplified. There's no fraction under the radical sign, so I'm simplified. I've got a couple of examples for us to work. Let's do the first one, the square root of 25 x to the fourth y to the sixth. I'm going to go ahead and do it in expanded form. I'm going to take the prime factors of 25, which is 5 times 5, and I'm going to expand x to the fourth and y to the sixth. Okay? Now, since this is a square root, my index here is a 2. That means in order for any numbers to come out of the radical sign, I've got to group up pairs of 2. Okay? There's a pair of 2. So it comes out as a single. It comes out as a 5. Well, y'all know the square root of 25 is 5. The square root of 25 is 5. And that's how that works. So let's pair up groups of 2 here. That comes out as a single x. This one would come out as a single x. That comes out as a single y, a single y, and a single y. And when I put these all back together, my final answer is 5x squared y to the third. Okay? I'm looking to see, is there a shortcut to this? Is there a shortcut to this? If my index here is 2, okay, I know the square root of 25 is 5. I want you to take a look at this, and this, and this. And I want you to take a look at this, and this, and this. Do you see any shortcuts? All right, let's take a look at the next one. All right, I'm going to take the square root of 50, x to the 5th, y to the 7th, and I'm going to take the square root of that. Now my index here is a 2, so that means I need to put together groups of 2 in order for them to come out of the radical sign. There's a group of 2 there, so I get my 5. Here's a group of 2 x's. It comes out as a single x. Here's a group of x. It comes out as a single x. Group y, a group of y, and a group of y. Now I got to go back and find out what didn't group together. Those right there stay under the radical sign, 2x, y. So my final answer here is 5x squared, y to the 3rd, the square root of 2xy. That's your final answer. See here with my x and y under the radical sign, the exponent on both of those are 1. Okay, that is simplified. Anytime your exponents are a number greater than 1 on your variables, it is not simplified. Now I'm kind of looking, this 5, this 2, that 1 right there, and I know that 2 came out. Just trying to see if there might be a shortcut. That, and that. What are you thinking? This right here together, these that all came out make y to the 6th times y. These that came out made x to the 4th times x. Do you see any shortcuts? You don't need to do any shortcuts. If you don't see it, you can do this whole thing in expanded form. Okay, so I'm just looking at the two answers and comparing. I'm really comparing the variable parts. And remember, my index here is 2. Take a look at how those answers are different. I notice over here my exponents are even. When your exponents are even, there's nothing left under the radical sign, because exponents with an variable terms with, let me say it again, variables with even exponents are perfect squares. Variables with odd exponents have a perfect square factor, but you're going to get an x and a y under the radical sign. All right? This here is the same as under the radical sign as having x to the 6th times x times, I'm sorry, let me redo that. My x to the 5th, I'm going to call that x to the 4th times x, and then y to the 6th times y. X to the 4th times x is x to the 5th. Y to the 6th times y is y to the 7th. Right there are my even exponents. Take your index of 2. What do you notice? This, and this. What do you notice here? Between, whoops, I thought I grabbed a different color. This, and this. And then what do you notice here, here, and here? Okay?